Hi. Let's talk factoring. Let's start with some basic factoring that we know already, and we're going to extend this looking at factoring with more than one variable and get back to that AC method that some of you have forgotten some from last year. Basic factoring problem here, I'm assuming you know how to do this. The idea of factoring is we are breaking this down into two binomials, x squared, so you've got x times x. We need two numbers you multiply to get 8, but add to get a negative 6. Right, so that's going to be a negative 2 and a negative 4, and that's how you factor that polynomial. Notice we're not trying to solve here. I didn't say set this equal to 0 or find x-intercepts. I just wanted you to break that down with factors, so there's no actual solving for x to do here. Now in the second example here, we have basically the same problem, but now we have both an x and a y. Don't let that change the way that you factor this. Still think about, well, how would I break this down? I've got an x squared here, so x times x. Now I need two things you multiply to get 8y squared, but then add to get a negative 6 y, basically, there. It's the exact same factoring that you did here, only these two are going to have a y in there as well. So you get that y squared on the end, and when you do your distributive property, or some of you learned it as FOIL, when you do your outer and your inner terms, you get that xy term in the middle. So don't let that second variable affect the way that you break things down. Also, don't let higher powers alter how you break things down. Here I've got x to the 4th minus 6x squared plus 8. Still breaking down, and you can see that minus 2 and minus 4 there again. However, now I've got x to the 4th, so I have to think, what can I multiply by itself to get x to the 4th? Well, that'd be x squared times x squared. So here's x squared minus 2, here's x squared minus 4 to break that down. Now if you look carefully, you'll notice there's more that we can factor here. Anytime we factor, we want to break things down as much as possible. X squared minus 2, not a whole lot we can do about that because that 2 is not a perfect square, but that 4 is a perfect square. And we could break down x squared minus 4 a little bit more. So this term is going to stay the way it is, this binomial, but x squared minus 4 could break down into x plus 2 times x minus 2. So that's what we call factoring something completely down. So now we've got three things actually multiplied together. So when you get your higher exponents, you kind of have to look to see, is there more that I can do to break these down as you go, right? Quick review of factoring when the a value is 1. I've just got an x squared out there. I've just got an x to some power out there, right? I want to dive in a little bit more with this difference of squares idea, because you'll see a lot of factoring things, sometimes even ACT type things, where we're just factoring things as differences of squares. And if you can just remember that anytime you factor something that's two squares being subtracted from each other, it's always going to break down into x plus and x minus the same number. This is a square here, so a times a would give me that a squared. That's your general form for factoring anything that's a difference of two squares. So I've got a couple of problems here which you can factor as differences of squares, but there's kind of a little bit more than just like the x squared minus 4 that we saw in that last example. All right, so x to the 6th minus 289. You may not realize off the top of your head that 289 is a perfect square. That's why you've got your calculator there. You can kind of check and take the square root, and you'll realize that the square root of 289 is 17. So this is going to turn into a plus 17 and a minus 17 at the end of our factors. But I don't just have x squared. If this were x squared minus 289, it'd just be x plus 17 times x minus 17. But we've got x to the 6th power, so I need x to some power times itself to equal x to the 6th. Well, that's got to be x to the 3rd. X to the 3rd times x to the 3rd. If I added those exponents, I'd get x to the 6th. So this is going to factor down like so. I mean, if it factored more, you would keep on going, but 17 is not a perfect square, nor is x to the 3rd power, so that's going to be as far as we can take that down. Right? Even if you've got a third variable mixed in, same idea. Look for this pattern, look for this form of this difference of squares and think, can I take, basically I'm taking the square root of this term. thinking, all right, well, the square root of 4 is 2, so this would be a 2 and a 2. Oh, hang on, this should be a minus. Why didn't somebody say something? This should be a 2 times 2. I've got an x to the 10th power, so I get square root of x to the 10th, or what times itself would be x to the 10th? Well, that'd be x to the 5th, and x to the 5th. Y to the 8th power, well, that'd be y to the 4th, and y to the 4th. Same term in both cases. It's a perfect square. This is a perfect square. It's 2x to the 5th, y to the 4th, quantity squared, to give you that term. Second term, obviously 5 here. Then you get z to the 18th, so z to the 9th times itself would give me z to the 18th, and that's how I factor that down. So when you have these binomials here, we've just got two terms with a minus in between, look for this difference of squares. It can speed things up and help you factor something that's a little bit more advanced when you've got more than one variable going on or larger numbers going on. So that's just a reminder of differences of squares. And the grand finale, the thing that many of you have talked about needing a little refresher on, and this is this AC method. We use the AC method when there's an A value different than 1. So I've got 2x squared minus 5x minus 12 here. Here's how we learned how to factor this last year. It's called the AC method because you start by doing A times C. Well, A is 2 and C is negative 12. So over here, I'm going to say I got 2 times a negative 12. That gives me a negative 24. And that negative 24 is like a target number now. I've got to figure out two numbers that I can multiply to get negative 24, but add to get this middle number, this negative 5. So I've got to think, what times what could give me negative 24, that when I took the sum of those, it would give me the negative 5 that's in the middle here. And this is, you got to do a little bit of guessing and checking and just sort of thinking about the factors of 24. And eventually you'll get down to, wait, 3 times negative 8 would make this happen. 3 times negative 8 is negative 24. 3 plus negative 8 is negative 5. So this 3 and negative 8, they're not solutions. They don't simply go straight into the factors. Those are the two values that you use to split this middle term up. We split this middle term into a 3x and a negative 8x. So I'm going to rewrite this, expanding that middle term. I'm going to make this a plus 3x and a minus 8x. The 2x squared stays as is. The minus 12 stays as is. Right. So these two numbers help me split that middle term up into two different expressions that's now going to allow me to factor two terms at a time here. I'm going to take these first two factors. I'm going to think about taking out a common factor. Notice there's an x in both of those. I'm going to factor that x out. That's going to leave me with a 2x here and a plus 3 here. Now I'm going to look at these last two terms, this minus 8x and this minus 12. You can see there's a 4 that's common to both of those. There's also a negative sign. And if you've got a negative sign on this term, you want to factor that negative out. So I'm going to factor out not just the 4, but a minus 4, a negative 4 out there. That's going to leave me with 2x, and if I take a negative 4 out of the negative 12, it's going to leave me with a plus 3. Now, if we've done things correctly, we should have a term in common here. This 2x plus 3 is common to both of these. I can factor that out as its own common factor. So I'm going to factor this 2x plus 3 out front, leaving me with an x in this term and a minus 4 in this term. And that is how I factor 2x squared minus 5x minus 12. You could always double check that you factored it correctly by multiplying those back together. Distribute, combine like terms. And in fact, when you distribute, you'll see all of these terms show up again, your FOIL thing happening, you'll combine back and you can get to that. So if I needed to set this equal to 0 and solve, let's say I could even go back now and say, well, what if I were trying to solve what made this equal to 0? Now I'd set these two factors equal to 0. Set 2x plus 3 equal to 0. Solve that, so I'm going to get negative 3 over 2 for an x value. and then x minus 4 equals 0, so x equals 4. So that's the AC method again. I've got one more AC method example on the next board. If you want to pause and try it yourself, you can, to make sure you've got the hang of it. If you just want to watch me do a second one, in class tomorrow we're going to do some problems where we're practicing all these factoring techniques. When we really dig into chapter 2, it's important that we can factor things that show up regardless of kind of what they look like, and especially if this AC method is involved. So here's one more problem, 3x squared minus 7x plus 10. All right, and I'm not going to set this one equal to 0. I'm just going to say let's factor this one down. So try it if you want. A times C, 3 times 10, gives me 30. That's my target number. I got to think what times what would give me a 30. That if I added those two things together, I'd get this negative 17. That's in the middle. All right, so these must have the same sign. They must both be negative. So I'm trying to get a negative 17 here. I kind of tinker around with it for a while and think 15 and 2. A negative 15 times a negative 2 would give me 30. And then a negative 15 plus a negative 2 would give me a negative 17. And these are not my solutions. These are what I use to split the middle term up. That minus 17x in the middle can split up into a minus 15x and a minus 2x. Now I look for common factors. Now I can not only take an x out, I can also take a 3 out of both of these. You can take out the greatest common factor. All right, so that's an x there and a minus 5. Again, take this negative sign out. If this is a negative, take that negative out with the 2. It's going to leave me with an x minus 5, and there's my common factor again. If you don't take that negative out, sometimes these don't come out to that common factor we want them to be. The key is to have that common factor that we can now bring out front and say this is x minus 5 times the 3x minus the 2. And that's how I factor using the AC method. It's a quick review of several different factoring techniques. Hopefully this kind of helped to refresh your memory on those, and we'll practice these in class tomorrow.